Now the question we would like to answer is how much does C2 consumption in the future change if we change consumption today? And we can answer this question given this expression here in a very general way by using the implicit differential. And so we're going to recognize that C2 is in some sense a function of C1, and that every time I want to take the derivative with respect to C1, or every time I take the derivative with respect to C1, it's going to change C2. And if we do that, we're going to end up with, well, let me write it out carefully so you understand what I'm doing. We're going to take the derivative of both sides. Now, we've got a bar on the u just so you recognize that it is just some number, just some quantity. It's a constant, and like a constant, it's going to disappear when we take the derivative of it with respect to C1. And so operating the left-hand side of this expression, we get u C1, u prime C1, plus beta. Beta just stays there. It's a multiplicative constant. U prime C2. And C2 multiplied by C2 prime, which is equal to 0. Now we want to solve for C prime 2. So let's rewrite this expression like so. And now remember, this is what we're solving for. We want to know how C prime 2 is going to change if we change C1 by a little bit. And the answer is going to be and maybe I'll just change the way I've written it so that we can have the beta in the front like that. And so if we change C1 by just a little bit, this is how we're going to change C2. And it turns out that I could rewrite this in a way that maybe you've seen. We can say that the change in C2 with respect to the change in C1 is equal to the negative of the marginal rate of substitution. What's the marginal rate of substitution? It's equal to the marginal utility of C1 divided by the marginal utility of C2. What does this look like if we put it on a graph? Well, what we've found is we've solved for the slope of a indifference curve. So these are different indifference curves. Remember that as we move up this way, we're getting more utility. That was capital U. Is getting bigger. And we actually found an expression for the slope of an indifference curve. So this is our marginal rate of substitution here. And if we equate it to this thing here, that's like what? That's like the rise over the run. And so the derivative of this expression with respect to C1, we can rearrange it and end up with the slope of our indifference curves that you would have seen in Econ 1000, and you're going to see a whole lot of in second year microeconomics. So we have an important relationship between the derivative and an economic concept of the marginal rate of substitution. To refresh your memory, here's a definition of the marginal rate of substitution. How much additional consumption tomorrow do we need if we're giving up some consumption today? Here's an iClicker question for you. Please pick the right answer. So press pause if you want to take some more time. I'm going to give you the answer, and the answer is the same. So the marginal rate of substitution keeps total utility constant, right? The same total amount of utility from C1 and C2 is going to be constant. Here's another question. Press pause on the video. Think about it. Remember, thinking and recalling information is a great way to remember information. And the answer is, once again, the top one. So I always remember that we've got rise over run. This over here is like our rise over run. And then we flip the subscript of the numerator and denominator when we're looking at marginal utilities. Sometimes we want to find the second derivative of implicit functions. So let's work through an example today. There's a little bit of a twist. So let's take a look here. We've got 2xy is equal to 10. Well, we'll take the derivative of both sides of the expression with respect to x, understanding that y is some sort of relationship with x. So you could think of it like this. Now we're going to have 2x y prime plus 2y is equal to 0. And that's our first derivative. Now I'm not going to rearrange it. I'm just going to take the derivative again. And when I take the derivative again, I'm going to have 2y prime plus 2x y double prime plus 2y prime, which is also equal to 0. Now, I'm going to solve for y double prime. So I've got 2x y double prime is equal to, oh, it looks like these two can just be added together. So I'll write it as 4 y double prime, and I'm with a negative sign because I moved it over to the right. Now I've got y double prime is equal to divide both sides by 2 prime over x. Now I could go a little bit further and I could replace y prime. So if I look over at this thing here, you can see that I could rewrite it as y prime is equal to y over x with a negative in front of it, like that. And then I could use this expression and sub it into here so that I get rid of the first derivative. And the first derivative is not in my answer anymore. Now I've got negative y over x times 1 over x. I'll just rewrite it a little bit to be clear, make sure I don't make a mistake. and this whole thing is going to be equal to 2y over x squared.